Hello, welcome to the Management Channel and welcome to Project Management Part 2. Hopefully you saw Project Management Part 1. So, determining the project schedule, we're going to take an activity A for the symbol, and how long it's going to take we're going to put down here. So, activity A is going to take 2 weeks. And we want to know what's the earliest start date and the earliest finish date. Then, we want to know when's the latest start date and the latest finish date, what those could be in order to complete the project on time. So first of all, we're going to do what's called a forward pass. We're going to begin at the starting event and work forward. So the earliest start time rule is if an activity has only a single immediate predecessor, its earliest start time equals the earliest finish time of the predecessor. If an activity has multiple immediate predecessors, the earliest start time is the maximum of all the earliest finish values of its predecessors. So, the earliest start time equals the maximum of all the earliest finish times. In the earliest start rule, the earliest finish time of an activity is the sum of the earliest start time and its activity time. So the earliest finish would be the earliest start date plus however long it takes to do that activity. In the previous example, it was 2 weeks. So let's take a look at a sample for the Milwaukee Paper Company. Earliest start time is 0. Earliest finish time is 0. Go with the whole program. This is the very beginning. So the first step is A, and it takes 2 weeks. The earliest start time, since it's the first step, it would be 0. The earliest finish of step A would be 2 weeks. It'd be the earliest start plus activity time, and that would be 2 weeks. So we'll file that up there. Next, we're going to do step B. Step B takes 3 weeks. The earliest start time of step B is 0 because it's going to happen at the same time as step A. And so the earliest finish of B is going to be the earliest start time, which is 0, plus 3, the amount of activities. So the earliest finish would be in 3 weeks. And then we're going to file that. Okay, next. We have activity C, which takes 2 weeks. Now notice in the upper left-hand corner, the earliest start time is 2 weeks because it can't start until A finishes. And so the earliest finish time would be 4 weeks. 2 plus 2. And now we're going to look at step D. It's the max of 2 and 3, steps 2 and 3, because D is going to take place after A and B. So the earliest earliest start time of step D would be the earliest finish of step B or step A. Well, you want the max, so it's going to be 3. Step D takes 4 weeks. The earliest finish date is going to be the 3 plus the 4 of the activity, so the earliest step D could finish would be in 7 weeks. And we'll put that up there. Next, we have the rest of them. And so you can see that E, F, G, and H. F and G can be done at the same time. They all have different earliest start dates, and they all have different earliest finish dates. So the earliest start, earliest finish Gantt chart for Milwaukee Paper. If you're using a Gantt chart, you would plot it out like this. And you can see each step, A, B, C, D, E, F, G, H, as we saw in the example of the diagram previously. Now we want to look at the latest start finish date. So the latest a step could start would be the activity can start and not delay the project. The latest start time for each activity is equal to its latest finishing date minus its expected duration. So the latest start equals the latest finish date minus the activity time. The latest finish time is the activity can finish and not delay the project. For nodes with one leaving arrow, latest finish for nodes entering that node equals the latest start of the leaving arrow. If an activity is an immediate predecessor to more than one activity, its latest finished is the minimum of all the latest start values of all the activities that immediately follow it. Thus, the latest finish equals the minimum of the latest start of all the immediate following activities. So, looking at our example here, we have the latest finish date of the project will be 15. And you would do that with each of the steps and each of the square blocks for each step of the process. Latest start equals the latest finish minus the activity time. So it couldn't start more than 13 weeks, and the activity time is 2, so the latest finish is going to be 15. And there, with all the numbers filled in, you can take a look at this and analyze it. I'm going to leave this for you to observe for a couple of minutes so you can see the difference between the latest start, the latest finish dates. You can pause if you need to go further. So using the same type of idea of a Gantt chart for the latest start, latest finish, with all the same steps, you'll see the Gantt chart time is all plotted out here. Now, slack time. After computing your earliest start, your earliest finish, your latest start, and your latest finish times for all activities, you look at what the slack or free time is for each activity. Slack is the length of time an activity can be delayed without delaying the entire project. Slack, therefore, is the latest time minus the earliest start time, or the latest finish minus the earliest finish. So, once you have that done, you compute the critical path. The critical path is indicated by the activities with 0 slack. In other words, there is no extra time there. So as we look at the steps, we can see the earliest start and the earliest finish times, latest start, latest finish times, and then doing the math accordingly, you'll see that step B is not on the critical path because it has some slack time. Step D is not on the critical path because it has some slack time, as well as step F, which has 6 weeks slack time. Everything else is on the critical path because there is no available free time or slack time. So the critical path for Milwaukee paper looks something like this. 5 activities are on the critical path. Step A, Step C, Step E, G, and H. Thus, D and F have slack time. So to try to understand slack time, the knowledge of slack time provides information for being able to plan all allocation of any scarce resources or something that might cause a delay. Control efforts are directed toward activities that might delay the project. If something it can be done within the next 2-3 weeks, then there's no concern there. Activity slack times are based on the assumption that all activities on the same path will be started as early as possible and not exceed their expected duration time. If 2 activities are on the same path and have the same slack, this will be the total slack available to both. Now let's look at 2 different methods that are used for project management: CPM, which is the critical path method, or PERT. CPM assumes we know a fixed time estimate for each activity, and there's probably no variation in the activity times. PERT, however, uses a probability distribution for activities to allow for some variability. But CPM is the most industry-preferred method. Budget control is also an important aspect of project management. Costs can exceed budget by having overly optimistic time estimates, having some unforeseen events or activities break in and disrupt the process, and unless corrective action is taken, serious cost overruns can occur. It may be possible to reduce the duration of a project by injecting some additional resources, but the motivations are to avoid late penalties for any monetary incentives and free resources for use on other projects. So we have what's called project crashing. It's not uncommon to face the following situations. The project is behind schedule. The completion time has been moved forward. The customer wants it earlier. Shortening the duration of the project is called project crashing. The amount by which an activity is crashed is, in fact, permissible. Taken together, the shortened activity durations will enable the project to finish on time by the due date. And the total cost of crashing is to be as little as possible. In other words, you may have to spend more money and resources to catch up or crash the project. So the steps are, number one, compute the crash cost per time period. If crash costs are linear over time, then you go crash cost per period, the crash cost minus the normal cost, and the normal time minus the crash time. Using current activity times, find the critical path and identify the critical activity. If there's only one critical path, and sometimes there are more, then select the activity on this critical path that, one, can still be crashed and has the smallest cost per period. If there's more than one critical path, then select the one activity from each path such that each selected activity can still be crashed, and the total crash cost of all selected activities is the smallest. Note that the same activity may be common to more than one critical path. In other words, if you have two critical paths in your project, one activity might be common on both. Update all the activity times, and if the desired due date has been reached, then stop. If not, you return back to step number 2 and start over. So let's look here at steps for crashing. We have this step here. It's on the critical path. The cost would be $750. This one is not on the critical path. The cost would be $2,000, and so on down the line. Obviously, step F has the lowest crash costs per week, and it's not on the critical path. So you calculate it out, and you look to see what you can crash at the least cost and still help bring the project in on time. So on our critical path and slack times for Milwaukee Paper Company, remember that step D has 1 week slack time, and step F has 6 weeks slack time. Step B also has 1 week slack time. So the other steps do not have any slack time. So you want to look to see where if you can crash on the steps with slack time. There are advantages of CPM and using the PERT method, especially useful when scheduling and controlling large projects. It's a straightforward concept and not mathematically complex. Graphical networks help highlight relationships among the project activities. And the critical path and slack time analysis help pinpoint activities that really need to be closely watched and are major on the critical path. Project documentation and graphics point out who is responsible for various activities, particularly useful in the Gantt chart. Applicable to a wide variety of projects, it can be used for anything. It's useful in monitoring and not only schedules, but also monitoring your costs as well. There are several popular software packages. Primavera for the Apple would be Mac Project. There's PERT Master, Visit Schedule. My favorite is Microsoft Project. Microsoft Project looks like this, much like a Gantt chart. And the thing that I liked about it was you can set this up to color code, and these bars will show up green, yellow, or red. Green if you're on time, yellow if you're starting to run behind, and red if it is behind. And you can visually see where everything is a go. And you can see there it has the steps, the dates, the start date, the finish date, and how they overlap. Some other resources, ensuring non-personnel resources are available for the project, if, when, and where needed. Additionally, you might need sufficient funds to support those necessary resources, so it's always good to pad your budget a little bit with a little buffer. You need to estimate the project's cost for your project budget. What's a project budget? Well, it's pretty much a detailed time phase estimate of all your resource costs for your project, including all the direct and indirect costs. Direct costs are salaries, specific materials, supplies, equipment, any travel you have to spend to perform your work on your project, and any subcontracts that provide support to the project. Those are all direct costs. Indirect costs are overhead costs, the building, the rent, electricity, and the admin costs that are external from the project. There's 3 stages of a project budget. The rough order of magnitude estimate. Big words, huh? It's the initial estimate of costs based on the general sense of the project work that needs to be performed. Then there's a detailed budget estimate, which itemizes the estimated costs for each project activity. And then the completed approved project budget. It's a detailed project budget that essential people have to approve and agree to support in order to move forward. There are 2 methods of preparing the estimate. Bottom up, which is develop detailed cost estimates for each lowest level work package in the work breakdown structure. And top down. You set a target budget for the entire project and apportion this budget among all level 2 components in the work breakdown structure. Thank you for viewing today. Hopefully you saw Project Management 1 also. Have a wonderful day.